So I'm going to be working with number 7. We're going to be working with this power series, and so we're going to be running through each individual part. So part A, we're going to figure out where does this series converge. So we're going to end up having some type of interval of convergence, and then show analytically or show the analysis that led you to that conclusion. Then what we're going to do is we're going to, in a sense, right, this is equal to f of x. And then what we're going to do is then we're going to try and figure out what g of x in relationship to f of x. But also some things that we know that if we have some type of original function, if we take the derivative or integral of it, we know that those will also have the same interval of convergence, just that you'll have to check the endpoints, determining whether the endpoints actually converge or diverge. And then the last part deals with, interval of convergence. What we're doing for part B is we're basically writing in terms of a Taylor series all the way out. In fact, it's more of going to be more of a power series. I think that's what they actually pretty much want for letter B. But anyway, so let's get started. So to figure out the interval of convergence, what we need to do is we need to start off with the ratio test. And so I'm going to start off by placing a +1 for n for each one of the values in the top. Need to make sure that it's also absolute value. But if we also have this understanding that it's absolute value, the alternating part of the power series is actually going to go away. So the -1 to the n power. So I'm not going to write that. So I'm going to write this as 2 to the n plus 1, parentheses, x minus 3 to the n plus 1, over n plus, and then this is going to be 2 because we're adding 1 to, in a sense, n. So instead of having n, right, it would be n plus 1, and so n plus 1, which gives you n plus 2. I made these absolute values too big. All right, then I'm going to multiply it by the reciprocal of that, but just the normal terms itself. So the 2 to the n will go on the bottom. The x minus 3 to the n is also going to go on the bottom, while the n plus 1 is going to go up top. We want to make sure that that is going to be less than 1, and we also want to say as the limit as n goes to infinity. Because remember, when we're counting up, in a sense, the summation, we're trying to figure out as n goes to some type of value, what value do I need to plug in x so that the value converges? So we are going to be assuming that n is going to infinity. Now to figure this out, what I'm going to do is I'm going to do a whole bunch of cancellations. A couple things, I normally don't write this all out, but since I actually have the time, so I'm going to write this as 2 to the n times 2, parentheses, x minus 3 to the n times x minus 3, over 2, I'll rewrite that. So 2 plus, or n plus 2, times n plus 1 up top over 2n, parentheses, x minus 3 to the n power. Now we can see that the x minus 3 to the n power, x minus 3 to the n power cancel. We can see that 2 to the n, 2 to the n cancel. Remember, this is still underneath the absolute value. We're still talking about less than 1, and we're still saying as the limit as n goes to infinity. Okay, so to clean this up a little bit, what I'm going to do is I'm going to eventually get this whole x minus 3. We're going to bring it outside because that doesn't pertain to the limit part. So we're going to say x minus 3, but it's the absolute value because I need to make sure that I'm talking about the positive and negative versions. Then I'm going to say the limit as n goes to infinity of n plus 2, n plus 1, but there's also that 2 out in front, over n plus 2 here. Now, what does this value equal? A couple things we could do: L'Hopital's rule. We could, say that it's equal heavy in terms of asymptotes, like kind of that we talked about before. But really, what the limit is eventually going to give you is 2. So we're going to get the absolute value of x minus 3, and then times 2 is going to be less than 1. So move the 2 over. So I'm going to divide both sides by 2. So I'm going to say the absolute value of x minus 3 is less than 1/2. Then from here, we're going to say that -1/2 is less than x minus 3, which is less than 1/2. Then we're going to add 3 to all 3 sides, or all, in a sense, all sections. And we're going to be left with negative, let's see, nope, not left with negative. We're going to be left with 5/2 is less than x, which is less than 7/2. So that is going to be my interval of convergence. But that does not necessarily mean that 5 halves and 7 halves are quite possibly values that could also mean that it converges. So we do have to check the endpoints. So which means I need to check when x is equal to 5 halves and when x is equal to 7 halves. So we're going to start off with the 5 halves to start off with. So start off my sigma notation. So this was negative 1 to the n, 2 to the n, parentheses, 5 halves minus 3 to the n over n plus 1. Okay, so does this converge? Well, I need to do a couple things right here. So I need to clean this up. So 5 halves minus 3 halves, that actually ends up giving us, so I write this as negative 1 to the n, 2 to the n, and this is actually going to end up giving us negative 1 half to the n. Now, this might look kind of weird, so I'm going to do a little bit of work off to the side. So this is really saying 2 to the n times, in a sense, 1 over 2 to the n times negative 1 to the n power, right? I can actually break apart this piece right here and break it apart to, in a sense, this setup. Really means the same exact thing, and what you can see here clearly that 2 to the n times 1 over 2 to the n, those two would end up canceling. And actually, so would the negative 1 to the n. Negative 1 to the n times negative 1 to the n actually ends up giving you negative 1 to the 2n, but the negative actually just goes away completely. But we'll end up doing that in a little bit. And then plus over n plus 1, still with the sigma notation. So what we end up getting, officially, we end up getting 1 up top over n plus 1. Now, there are many different ways to figure this out, but the biggest thing is just kind of determining, in a sense, the power that's going to be right here. The power is 1. We normally say p series. Now, we can't say p series because of this plus 1 or minus 2 or other things like that. So you would actually have to do a comparison test or limit comparison. But most of the time, the plus 1 or the minus 2 really doesn't affect it enough to change the convergence or divergence. So we do have this understanding that if it is 1 over n, we know that it's a harmonic series, and so what ends up happening is that this actually diverges. So which means that we are not including 5 halves. But if I end up using x is equal to 7 halves, same deal, sigma notation, negative 1, 2 to the n, parentheses, and I'm going to write 7 halves minus 3 in here to the n over n plus 1. Now, you're going to notice that there's going to be a lot of the same types of values that are going to happen here. What ends up happening here is actually, in this specific section, I get 1 half to the n, and that's actually going to cancel with the 2 to the n. So I'm actually left with negative 1 to the n power over n plus 1. Now, this leaves us with an alternating series. So if it is an alternating series, we know that we can use a different type of test to help us figure out convergence than divergence. So if we're using alternate series, does the series decrease in magnitude? That it does because of this n. Does it go to 0? That it does, right? Because if I end up having this going to infinity and is going to be increasing in the bottom, which is also in a sense going to be going to 0. And then the last thing, is it alternating? And of course, because it has that negative 1 to the n power, so we can say, because of alternating series, this is going to converge. So the big thing that you need to remember that if it looks like some type of if it looks like some type of harmonic series, like that 1 over n, or 1 over n plus 2, or 1 over n minus 3, those are all going to diverge. But if they have the alternating piece to it, that negative 1 to the n or negative 1 to the n plus 1, right, then it's going to actually diverge, or then it's going to actually converge. Okay, so that means that this value converges, so that means that x is equal to 7 halves is going to be actually included with the interval. Now moving on to part B, what I'm going to do here is I'm going to write out each one of the terms to just kind of help us along with trying to figure out some of the values. So I'm going to write the sigma notation. Again, that was a poor sigma notation. So n is equal to 0, goes to infinity, of negative 1 to the n, 2 to the n, and parentheses x minus 3 to the n over n plus 1. So let's run through, in a sense, what each value would be. So when n is equal to 0, well, for the first value, that would just be 1, because negative 1 to the 0 power is going to be 1, times 2 to the 0, which is also going to be 1, times 1 again, over 1. Okay, so that's when n is equal to 0. So this is all going to just evaluate to be 1. Now, when n is equal to 1, that means that this value right here is going to end up becoming a negative, so we're going to get a negative value. 2 to the first times x minus 3 over 2. You can see that the 2's cancel. We'll worry about that in a little bit since we're trying to worry about, we're trying to write the first 4 terms. So let's go out to n is equal to 3. So n is equal to 2, and then n is equal to 3. Okay, so it's going to go back to positive again after the negative. So it's going to be 2 to the second, parentheses x minus 3 to the second power over 3. And then minus 2 to the third, x minus 3 to the third over 4. Okay, and then I can finish this up by dot, dot, dot. Okay, let's clean this up a little bit so that we can kind of have some types of, values to help me go along with it. So this is going to be 1 minus parentheses x minus 3, and then plus, this is going to be 4/3 x minus 3 squared, and then minus 8/4, which is actually just going to be 2 parentheses x minus 3 to the third power plus dot, 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 dot. Okay, so this in a sense is my f of x function. Now what I need to do is I need to take a look at a couple of other things. I know that g of 3 is equal to 5. I also know that g prime of x is going to be equal to f of x. And what I'm trying to do is I'm trying to figure out what is, in a sense, the Taylor series. It's actually supposed to be the power series. So the power series in relationship to g of x. So I'm going to write it like this. This is equal to g prime of x. Well, how do I get g of x? Well, to get g of x, I would need to do the integral of g prime of x. Right, that would just get me back to the original. The derivative of an integral is just basically the original, or the derivative of the integral equation is going to end up giving us just back to the original and vice versa. And so what that's going to be equal to is going to be the integral of f of x, which means that we're going to write this as the integral of 1 minus parentheses x minus 3 plus 4 over 3 x minus 3 squared minus 2 parentheses x minus 3 to the third power plus dot, 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 dot. Okay, in parentheses. And then since we're differentiating, we're going to say dx at the very end. Okay, so moving on from here, what we're going to eventually get, we're going to get something that looks like this. So normally whenever we do some type of integration, we have a plus c. So we're actually going to start off with a plus c. So c plus the integral of 1, which would just be x, minus the integral of that quantity, so x minus 3 to the second power over 2, then plus 4/9 x minus 3 to the third. Now, why is it 9? Because if I take that power, raise it, and then put it underneath, I'm really just doing 3 times 3 at the very bottom. So it's going to give us 9. And then minus, this is going to end up giving us 2/3. Is that 2/3? I think that's 2/3. I think I might have made a mistake in my equation. Oh, well, anyway, so 2/3 parentheses x minus 3 to the fourth power. Nope, that is not right. So, right, since you were increasing it to the fourth power, we're going to say that we're going to place the 4 in the bottom, so that would be 2 over 4, which would actually be 1/2, so that'd be actually over 2. And then plus dot, 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 because it keeps going on forever. Okay, so now this is equal to g of x. But how do I figure out, in a sense, what is c to help me figure out what this power series is going to be? So I'm going to write g of 3, which is that value right there, which means that when I place in the value x is equal to 3, something is going to happen. So what's interesting here is that when you place in the 3, we still don't know what c is, but we know x is going to be equal to 3, and then minus This is just going to give us 0 plus 0 minus 0 plus 0, and so forth down the line because it is centered at 0. So I do also know that g of 5 or g of 3 is going to be equal to 5. So we can say 5 is equal to c plus 3, bring over the 3, and so I get 2 is equal to c. So my power series, what it's going to look like is going to be the following. I'm going to write this as g of x is equal to 2 plus x minus parentheses x minus 3 to the second power over 2 plus 4 ninths parentheses x minus 3 to the third power. Now that's actually my four first terms. So I actually don't even need to go any further. But I do want to actually clean this up a little bit. So to clean this up, we notice that the center is at 3, so we need that minus 3 piece. So the way to organize this, I can actually rewrite this as g of x is equal to 5 plus parentheses x minus 3. And in that case, we still get the overall result of 2, but we still keep those parentheses that it's centered around, so that minus 3 piece. And then minus parentheses x minus 3 over 2 to the second power plus 4 ninths parentheses x minus 3 to the third power. Okay, so this is going on rather long. I'm at about 16 minutes. I'm going to stop this right here, and I'm going to finish up part C in a little bit.